last meeting we discussed about data analysis, simple data analysis, right? And you have a lookup table that you created in the Notepad with format separated, right? And then you save CSV. Right? So the same thing for your group project. If you want to load, you can put into a CSV file all the text, and then you can put it up. I can give you example.
Okay. By the way, sir, for our midterms, in what format will it be?
Okay, your midterm will be in Moodle in Revoledo, and it's the same as the quiz last time. Okay.
So multiple choice.
Yeah, multiple choice. Okay, but it takes longer because you will have coding.
Okay. Okay.
Okay, and then you will select among the possible answer. So be very careful in the midterm, especially because the answers are not just one, but multiple sometimes. Okay, so then you need to select all possible correct answer, not just one. Otherwise, you will be deducted with 25% minus.
Okay.
Sir, so all of it will be in multiple choice.
Multiple.
It's like last time.
Correct.
Oh, okay. But we have to code to answer the questions.
No, the code is already provided, so you just need to select. And then if you want,
so we like answer the what will the program do, something like that, right?
Correct. And then if you are not sure, so you copy and paste in your Python or in your Jupyter, and then try on it, and then you can answer. Okay, so yeah, it's practically very easy, but the tricky part is actually to answer all the possible correct answer there.
Okay. Don't make it too hard, sir.
Yeah. It's multiple choice. It's not so hard. Right.
Yeah, but it's tricky. That's why.
It's tricky, correct. So, okay. So anyway, the percentage of midterm is rather small. So the percentage of the group project is actually very big. Now that we have only 4 people here, Pancha, who's your original group member?
William and Kenzie, yes, and both of them left IPE.
Okay, in that case, do you want to join with Michelle?
I think it would be fine, yes, and we can discuss the project.
Okay, so please contact each other in that case, and you can change the project as you wish. Yes.
Okay, sure.
Sure. So today I would like to continue what we discussed last meeting. Let me share my screen. So what we discussed last meeting, it was simple data analysis, is it? Simple data analysis. Okay, so this simple data analysis using Python is like the beginning, okay? Before I explain about pandas and NumPy, so I give you like overview what you can do with it. So last meeting, we discussed about the data cleaning, and feature engineering, meaning you derive new variables based on data. So today, I would like you to practice about analysis of each variable. Okay. So you can follow this in Revoledo, right? Simple data analysis. Yes. So
Sir, is this the same link as last week?
correct, correct.
This is the same link. Yes,
The
okay.
same link as last week. Okay. So last week you already have this table. So if you did not get this table, so please try to make it so that you will get this table again. Okay, because we will analyze this table. Okay, so now based on this table, now you want to know, okay, of course, now based on this table, I want to know, say for example, for how many apple, how many banana, how many cherry. Of course, this is only 10, so it's easy to count by hand. But in real data, you have million, right? Okay, million of rows that you cannot even see, and million of objects, or probably hundreds of thousands of objects. Then you start to analyze. So the first analysis that you should do is actually what is called distribution. Okay, so statistical distribution. Hey, by the way, did you learn statistics before?
We are learning it right now in this
Right
semester.
now. Okay. So then you know what is distribution, right?
Yes.
Okay. So you know what is mean, standard deviation.
Yes, we know it.
Okay, good. Did you also learn linear algebra before?
Not sure.
No. So meaning no.
No.
Did you learn about matrix in high school?
Yeah, we learned about metrics.
How about you, Joy,
I learned about
and
metrics.
Livy, Michelle?
Yeah, I think it's mandatory in high school, sir, to pass
Okay. Okay. So
metrics.
you
Yeah.
know how to do matrix multiplication.
Yes.
Okay. Good.
Yeah, but I kind of forgot since it's been a
That's
long
fine.
time.
That's fine.
Same, sir.
At least you know, right? Michelle, no problem. You have learned that in high school, right?
Yes, I have learned that, but I'm not good at it.
No need to be good. I'm just telling this that you can now using Python to compute for you.
Oh, okay, sure.
But if you don't know anything about it, then I'm in trouble because how can I introduce some concept that actually you don't know anything about this, right? But once you know what is matrix, then that's fine. Okay, so let's come back here. Say if you have a data table, okay, so this is your data table last time. So this is your table. So I have it here from last week. Can you get your own table in your Jupyter or in your?
Yes, I saved mine from last week.
Okay, so
And I just
how about
opened it.
you, Joy, Livy, Michelle?
Wait, I'm looking for this
Okay. Okay.
in Jupyter.
If you save it last week, then it should be fine.
Sir, one question. How did you eliminate the none?
None.
And
So how to
because mine has a lot of none.
Yeah, me too.
Okay. So in the data or in the
table?
in the table? In the table, I did not get any none.
Maybe I can share my screen.
Eliminate is replace. Like this.
Oh, Oh, using replace. Oh, okay.
Okay. So in the table, what is the column name, color, for example, replace NP none with certain value that you want. So count here
Oh, okay.
43, but actually you're supposed to make it, for example, table count mean. Oh, table is not. Oh, okay. I need to run it again. So the mean is not working. So I need to change that mean to well, oh, mean, correct. Still not working. Anyway, 33. Come back to 33. So if you make mistake, you can just run all. Okay, so once you have this data table and without none, right? Then you compute again. So if you compute again, the none will be removed automatically because your data does not contain none anymore.
Oh,
So
yeah.
Yes, please.
can I show you my
Oh,
screen?
please, yes.
So this is the last time I
Yeah, it
did
works,
it
right?
was you see this is in 28 in 29, and today if I want to press default there's an error.
Yes, because last time you run it, but this time you don't run it.
So I need to run it again.
Go to
Or
kernel. Okay, so I will do it for you. So you see the kernel there? Can you?
this one?
Yes. Click that and
Yes,
run all.
this one.
Correct.
Okay. You start kernel.
Yes.
Yeah,
But
start.
yes, you run all. There. Now your table is in the memory.
Oh, I see. Now I can continue.
Yes. Now you can continue. Okay.
Okay, thank you.
Here it is not working because it's only text. Jupyter store your text but does not run.
Oh, I see.
So it's not in the memory.
I see. So if it's on saved with Jupyter Notebook, it will be saved as this data type.
Correct.
Oh, if
That's
spider like this.
inside that, if you open, that is only JSON.
Which one?
That inside this one is actually JSON file.
Oh, I see.
It's a text file. Okay.
Okay. Okay then. I'll stop my
Okay.
screen.
Yeah. Okay. So everyone get the table.
Yes.
Livy, Joy.
Sir, I think I messed up. Last time I got the table, then I want to like remove the nan, right?
Correct.
But then Nothing appears. Name table is not defined.
Oh,
Right, I'll share
You
my
have
screen.
you have to rerun it again.
you need to rerun it again.
Yeah. Mine also happened like that at
Hmm.
first. Go to the
Restart the
kernel.
kernel.
Restart the kernel,
Start
run
run
all. Okay, restart the kernel, run all, then you can get.
It's not working.
Can you share your screen then? Name table is not defined. Oh, it's already there, right?
This one, I move it here because I
Ah,
thought
yeah.
like if I put it before, it will like define the table, but then no.
Okay, can I? Oh, table is defined there, correct? Oh, PD is not defined. Can you go up?
This used to work, but then it
Yeah,
doesn't
yeah,
work
okay.
now.
Can you go up until up? Number 1. Oh, okay. So you go to kernel, run all, run all. Yeah.
Restart and run.
Correct, correct. Yes, you run. So let us see where it is stopped. It ran 12, run. Oh, that one, number 14 is not working. So 13 is working, number 14 is not. Why?
I do none of IT.
Missing, what is that? What is it called? Missing ID column. Oh, because your ID. Okay, so you can remove the ID, that line. No, you just comment it. You comment that line, the third line you can comment.
This one,
Yes.
I delete this.
Slash, no, control slash.
Control slash.
Yes. Yes. And then you control enter again. Now working, right? Okay.
Yeah.
So now working. Next. Okay, that's your work. So everything okay now.
Okay. Okay. Thank you, sir. Oh
Okay.
wait, no.
You have no revenue yet.
Oh, because it's here. It's supposed to be here.
Okay, so you put it down. Yeah, that one.
Yeah.
That is down. You can you see the arrow down there.
Oh, I can just press this
Yes, you can
one.
just press that. It will go up.
Oh, okay. Okay, thank you, sir.
Okay, Livy, no problem. Can you get your own table?
Yes, but I still don't have the profit and
Okay.
there is still the none.
Okay, can you share your screen?
Yes. Mm, Where is my?
So if you have no profit yet, you just get that formula on the revenue and profit.
This one.
Okay. Yes, you just copy and paste from the.
This one.
Yes. Did you remove the none?
Not yet.
Oh, so you replace first in that case.
Mm,
Yes.
uh,
Only that put number 14.
Wait.
Oh, that no, you copy everything that. Yes, only that. Table is not defined, meaning you can you go up a little bit? Go up a little bit again. Oh, your table is defined. Okay, can you go to kernel, run all? Okay. Let us see where it is stopped. Okay, 11 is no problem. 12, 14, no problem. Okay. Then now you can copy the
Where is it none?
yeah, no problem, because that is computation, right? Not the data. So in that case,
Oh,
you
okay.
just compute again.
So
You copy the next one. Yeah, that one. You run it. There you get. Okay, perfect. So let's go. So I will share my screen now. So now you have your data table. Okay. You can also calculate your profit. Now we want to chart the distribution, right? So here it is. You can use what is called value count. Okay. So I copy and paste this value count here. Oh my goodness, what happened to this? I will run again. Oh, I still have error. I think I have some problem. Oh, anyway, so here. So if you have if you run this, okay, table object value count, okay, then you will get this output. So the object consists of banana, cherry, and apple, and then how many banana, how many cherry, how many apple. Okay, so H here represent these values, and then now you can plot them. So to plot, so you just put H. H is the name of the variable here. This is the one, and then you just put plot. What kind of plot? You can have bar chart. You can have many other plot that you want. And this is the title. This is the size, the color of your plot, and what is the name of the X and the Y. Okay, can you try this? So in the meantime, I will fix my table. Oh, because I did not name it.
Sir, plot is
Yes.
because we use matplotlib. That
Right.
one.
Correct. But inside the Panda,
Oh. What is Panda actually, sir?
okay, Panda is like database, right?
Yeah.
So Panda is actually like a data analysis tool, which is similar to database, but also similar to Excel.
It's like a library. No.
It's a module. It's a module, free module that you can use to do a data analysis.
Oh. Okay.
Okay. So
Okay.
there are many modules in Python. Okay. The one that I will introduce you is the one that is pretty famous. It seems like if you know Python, you know this one also. So everyone will know about it. Okay.
Okay, understood.
Okay. So like NumPy, Pandas, Matplotlib, these are the three most well-known Pandas Python module. Okay. So can you make the plot already?
Yes, mine is working.
Oh, that's good. I think. Okay. Now I have my table running. Yes. So once you have your table running and you can plot, okay, you can plot other variables as well, right? So you can change the color. If you don't like pink, you can change it to blue. Okay.
Sir,
Yes.
the chart is only bar chart. Can we like change into like pie chart or
Oh, you can have many different chart. And
Just change the type,
yeah, you
the
just
kind.
change the plot. Okay. You can have box plot. You can have. Here it is. Let me share my screen to you. So if you search in the documentation of Pandas, this is the, you see this? You can have line, bar, horizontal bar, histogram, box plot, kernel density, area, pie chart, scatter, and hex bin plot. So these are the possible values, right?
But when I tried to change the bar with pi, it shows error.
Yeah, it doesn't work with pi. I don't know.
Oh, it doesn't work with pi.
Yeah. I think because pi has to be in percentage, maybe.
I don't know. You can check the. Let's try to search in Google. Okay, Pandas plot pi. Right. Show values. It doesn't say must be percentage. Plot pi. Oh. Let's try.
Oh, it has to be plot dot pi.
Yes. Dot pi. What is your command there? Oh, just plot, right? If I put pi, it doesn't work. Yes, an error. Let's see.
Yes, plot.py works for mine.
Plot.py works.
Yes.
If only plot only is not working.
Yes.
Okay. So bar is working. So can you share your screen, Pancha? The plot.py.
It's pretty simple. Basically,
Okay.
just
So it's
h.plot.py.
plot.py. Okay,
Yeah.
very good.
And I think we can edit it like put some functions like color and etc.
Correct. So, and you see that the access subplot there.
Oh,
How
yeah.
to remove that?
Sorry.
How do you know how to remove that?
We changed the title.
No, you put a semicolon. You try to put semicolon after the pi. No, outside.
Here?
At the end.
Oh, yes.
Oh, yes. Okay.
Oh, this is why there's a semicolon here.
Correct.
Okay.
Okay. So if you don't put semicolon, it will tell you the
the origin.
Yes, ugly object, right? So to suppress that object, you put semicolon.
Okay.
Okay. So
Sir,
yes, please.
when I try to h.plot, it shows that function object has no attribute. Plot.
Can you try to share? Oh. Okay, so we go back to the 22. Oh, because your value count does not contain value. Table value count is only. Can we go up? Can I see your table? Okay, and you're supposed to have value count. Oh, I know why. Your value count should be with parentheses.
Here.
Yes, parentheses, open and close, after, at the end. Open and close. Yes, one more. Yes. You run it. Now you can have it.
Oh, okay.
Try. See, you have it. And try again.
Okay.
Great. So you have it.
Okay. Thank you, sir.
Okay. Livy, no problem. Michelle?
Yes, no problem.
Oh, cool. Good. How about you, Livy?
I have a question.
Please.
Wait, I'll share my screen.
Oh,
How
you
to
make it.
yes? How to turn this to this position? Because
What?
it is like horizontal, right? I will make it like vertical. So
Oh, how to make it automatically vertical.
yes.
To that. So if you don't know, you can Google it, okay?
Okay.
Okay, so I don't have any answer. Okay, but Google probably have it. Or someone group in say Stack Overflow group probably will have the answer.
Okay.
Okay. So automatically set for you. So in that case, it seems we cannot change that. But if you want to change that, you can, but you need to know more detail about Matplotlib. Okay. So I cannot answer that. So Google can answer that. Okay. So let's do the next one. Say, the next one is what is called crosstab. So I don't know why they changed the name of, in pandas, there are two. One is called crosstab, the other one is called a pivot table. So do you know what is pivot table?
Sorry, sir. What table?
Pivot table.
Oh.
Have you ever done pivot table in Excel, for example? Do you know what is pivot table? Pivot table. Pivot table, like something like this.
What's the difference with normal table?
Oh, okay, good. pivot table will create a new table from your normal table. Okay, example, your table earlier. Okay, this is your table earlier, right? Table here. So then you want to have the index here is object, the column is color. Then it will create a new table based on your original table with the new columns, okay, and new rows. The rows here is object, apple, banana, cherry. And then now the content of this new table, which is the pivot table, is depending on the function that you set. For example, in here I set for sum. Then it will calculate how many sum of green apple, how many sum of the revenue. Yeah, in here the value is revenue. So the revenue of green apple, how many revenue of red apple, and so on.
So pivot table is like with two variables, right?
Can be more than two.
Oh, yes.
Okay, pivot table is kind of aggregation. So you analyze the whole table, okay, automatically into a new table. Okay, so
Pivot table is temporary.
a kind of temporary or not is up to you. So what is the definition of temporary in this case?
I thought it will not last that long. So only because we assign it, it will stay that way.
So pivot table is basically a derived table, right? A derived table from the original table. Your table data, you have a table data, right? So now you want to extract certain value, okay, from this table data. Okay, so there are many ways. One is using crosstab, the other one is using group by, and again the other one is using pivot table. So let's discuss it one by one. Okay. So okay, first thing first, box plot. You know what is box plot? Box plot is a plot, okay, for one variable, for example, in here, price, right? Box plot is a statistical way to know whether there is an outlier or not. So in box plot, the plot is something like this. Can you see it? Okay. On the top here is the maximum price. In this case, I put column price, right? And at the bottom here is the minimum price. Okay. And then you will have the green here represent the median. And this is like the first quarter and the third quartile. The first quartile and the third quartile. So if your data has certain outlier, then it will become very long outside the first and third quartile. So
it's like candlestick.
No, it's different.
Different.
But candlestick in finance is based on open and close.
Right.
So this is not candlestick. This is a box plot. Is representing your whole column, one column, to see whether there is an outlier or not.
Okay.
Shape is look like candlestick, but the meaning is different. Okay. In box plot, you will see if there is outlier, it will have star in there. If no outlier, there is no star. Okay. So basically, you want to know why you want to know outlier. Okay. So if you want to know why you want outlier, imagine, okay, you have a data of 1, 2, 2, 2, 2, 2, 3. What is the average? Okay.
Two.
So 1, okay, 2, 2, 2, 2, 3, right? So I put this as A. Okay. So now I want to get the mean, right, of A. Oh, mean is not defined. So NP mean. The mean is 2, right? So now what happened is if you have outlier, okay, of the same data here, okay, suddenly you mistake in typing. Instead of 2, you type 200. Okay. So what is the mean now? Become 35, right? So what is the median? What is the median of A? Still 2.
Still 2, yeah.
Can you see it or not? That median is robust. If you are outlier, okay, your data analysis will not change so much, okay, unless you have too many outliers, right? So, but if you have only one mistake, the median will not change. But if you use mean, it
It
suddenly
will change.
shifted so much, right? So that's why, but you often use mean, right? Some very rare to use median, right? So in that case, be very careful, okay? So mean average, right? So what happened is by putting box plot like this, you will know, okay, whether your data actually have outlier or not, right? If your data has outlier, so be careful, don't use mean. So you should use median. Is that clear? Now, Panda has a technique to give all your statistics of one variable. Say, in here, the method is called describe. So, say, you have a table revenue describe. Okay, so I'll put here, table revenue describe. There. So, remember, table revenue only, it will give you the revenue, right? But when you put describe, describe, yes. So it will give you how many, the count represent how many data in that table revenue column, and then the mean, the standard deviation, the minimum, the maximum, and the quarter. Okay, so the first quarter 25%, the 50% is the median, and the third quarter, which is 75%. So from this quarter, then you can actually plot the box plot a while ago. Until here, is it clear?
Yes, it's clear.
Any question? So in statistic, you want to know, okay, so first the distribution, right? Second, you want to know whether there's outlier. Okay. Third, of course, you want to know the actual statistic, which is the mean, standard deviation, okay, and quartile, first quartile, second quartile, third quartile, and minimum maximum. Okay. Now, if you want to analyze two variables, two columns, okay, there are several ways. One is to use group by. So, say in here, okay, in your table, table revenue group by object. So that means you want to get, okay, you want to get the revenue of each value of the object. Okay, how much apple will give me revenue? How much banana will give me revenue, and so on. Is it clear?
So it will sum all of the revenue gathered by Apple.
Correct.
Oh, okay.
Okay. So this is important, right? So you often face this kind of situation when you analyze your data, okay, in one column, okay, and then you want to check another column values. Okay, so one way is to use group by. Is it clear?
Yes.
Second way is to use crosstab. Okay, you will get exactly the same, but now more refined. You see, in here you sum everything, right? In here, you want to know how much, okay, for the crosstab revenue object. So this is the same exactly as before, but now for each revenue, okay, you want to know how many percent in this case. Total is 1. Can you see it? So 33% of Apple is 360. 33% is 500, and 33% is 750. So this is more detailed. Do you get this or not? Joy, Didi? In group by here, you want to sum, and then you get the summary, right? Now you want to give more detail, okay? Now you expand, you want to give more detail. How many percent for each revenue value? So banana was bought at 60, at 84, and it's at 150 and at 315. That's why 25% off. Can you see that? Well, cherry was bought as 50, 330, 405, and 1,000. So then the average is this one, right? Okay. So then you can also get the mean. Okay. Say based on the color, you want to get the mean, you can also do that. Okay. Aside from revenue, you want to get from the distribution of the profit, for example. You can also do that. Do you get the meaning of this or not?
Yes, sir.
I'm a
Yes.
bit confused, sir.
Okay, which one?
The one with cross tab.
The one with crosstab is confusing.
Yes, I'm a bit confused on how to read the table.
How to read the table? Okay.
Yes.
To do it easy, right? It's just copy and paste. The meaning is here. Example, so cherry was one of the revenue was, say, cherry was bought 4 times, right? Is that correct?
Right.
Cherry was bought 4 times. So one at 50, revenue 50, one at revenue 330, one at revenue 405, and one at revenue 1000. That's why it's 25%. The total here is normalized to be 1.
So is it correct that this is my interpretation, right?
Please.
So the first transaction is cherry, and then banana, and then cherry. And at that point, so about the revenue is 330.
330, yeah.
And then by adding 1 apple, the revenue is 360.
No, this is separate. In this crosstab, you want to know what is the revenue only by cherry alone. Only by apple alone. Only by banana alone. Right? So in your table, you have, where is cherry? Here. Cherry is number 8, right? Oh, there, exactly. So if you see the table here, cherry was bought 4 times. Number 7 to transaction 7 to 10, right?
Right.
You look at the revenue here is 330, 1050, and 405.
Oh,
You see this? The revenue, not the profit. Revenue is the 3rd column before the last.
Okay, I understand.
Okay, that's why, because it's 4 times, so it's 25%, isn't it?
Yes.
That is what is reflected there in the crosstab.
Okay.
4 times. Okay, so of course the data is only small or only time data, so actually can be seen easily in the original data. Again, your real data can be very big. Okay, then this percentage can have some meaning. Okay, so the same thing with group by and crosstab here. Okay, when you normalize, the sum of each column become 1. Okay, is it clear?
Yes, it's clear, sir.
Very clear, huh? Okay, good. Now, you can also do a group by 2 columns. You see this? So group by, now you put a list of columns or more than 2 columns. Okay, so table object and table color. So it will group by object and color. Then you get the sum. Can you see it? So that means how much is the revenue of apple green and apple red? Oh, now you can separate them. Okay. In fact, cherry is only red, no green. Okay. So with this, in business intelligence terminology, this is called drill up, drill down. Okay. Drill down means you go into more detail. Okay. Drill up means you aggregate. You summarize. Okay. So the next technique, aside from group by and crosstab, is to use what is called pivot table. Okay, this is the 3rd technique. So using pivot table, okay, So you can put the column and the row here is called index, and then the cell is in the values. Can you see this? The cell is in the values, and then the function is up to you. You can put NP sum, NP mean, NP count, or len. Okay, so then you will have different table. So in here, I put the column is color, the row index is object, and then the value that represent revenue. And then I want to get the sum for each. So if you look at this table, it's exactly the same as this table, isn't it? That a while ago we do using group by. Look at the value there. Okay, but in pivot table, you will tell everything. Okay, so that's why you have none in here that represent there is none apple that is yellow. There is no apple that is yellow. Okay. You can also remove the none using fill value. So if you use fill value, say for example 0, then it will change all the none become 0. So instead of sum, you probably want to count the frequency. How many times it happened? Then you need to use anonymous function here. Okay, the aggregate function is an anonymous function to count the number of unique value. So until here, what do you think? What did you learn?
Sir, I still have I'm still confused on how to read the last pivot table. There is a taste above the color. Is it like crunchy green, juicy
Yes.
red, and sour red?
No,
Oh.
the taste is crunchy, juicy, sour, sweet. The color is green, red, and so.
Oh. But there is no
The sweet
no
have
numbers
three.
for the
The
taste.
sweet have 3 color, but all others there is only 1 color.
Oh, okay, I see. Yes. Okay.
Right? The data is
Yeah.
small, only 10 rows.
Yeah.
So, yeah, this is this simple data analysis is just a demo, okay? How you will analyze the data. Please remember this. When you analyze the data, number 1 is to clean your data, okay? After that, you derive new variables, new columns, okay? After that, you do one variables, each of 1 variables. Then you do 2 variables. If you finish until 2 variables, you create thesis already, isn't it? Usually in Tetra like that. So if you want more, then you can do a modeling, okay, and so on. So again, this is called simple data analysis. So it's like the basic that all data analysis must reach at least this level. Okay, at least.
Sir,
Yes.
what's actually the meaning of data cleaning, sir?
Data.
Cleaning.
Oh, you clean the data. So look at the example there. right? Your original data was like this one.
Mm-hmm.
See, 1001. You don't know what is this original data. What's the meaning of 1? What's the meaning of 2? Right? And you have many nuns there.
Yes.
Yes. And then when you actually do the data cleaning, okay, then you see, say you have a lookup table, okay. From the lookup table, now you get the actual data. See, if you look at this, no, now you get the real table finally. Right?
So for the lookup table, we need to make it by ourselves.
Correct. You make it by yourself. In reality,
Mm-hmm.
so in reality, it's the other way around. Okay. This is probably the data that you receive. Okay. This is the data that you receive. And then what you will do is you create a lookup table. And then you will create the first data table earlier. This is the one that you will analyze anyway, finally. And then you will put back into the lookup table so that for each of this data will be shown in the correct properties. Do you get it?
Yes, sir.
So this is I don't know. I will search for it. Where did I put it? Okay, here it is. So this is the data analysis that I did for Toyota in Japan. Okay, based on the data that consists of different data. So this is the original data from here, from 2005 up to 2017. Right. So if you look at the original data, is something like this. Let me open. This is just example of data analysis. Huh? Oh, there. The data is something like this. Can you see it? This is the name of the road. This is the date and so on. Let me put it up there. So who is the investigator, right? What district, the hours, years, and the city. So a lot of empty. You see this? Right? A lot of NA. So the original data is like this. And usually, if you have multi-years data like this, different year will have different data. See? Say in 2017, for example, you will have a totally different data. And then now you need to merge all this data into the same. So in here is the same, but now you have a new data here, report number. Can you see it? In 2005, you don't have report number. In 2017, you have report number. And you have different columns that earlier you don't have, now you have. So data cleaning means now you combine all this multi-years data, okay, into one single table. So the one that you cannot, you just put it as an A. You cannot combine, okay? You just put it as empty. So, and when you combine this data, eventually you will have millions of rows, you know. Okay, so once you have a million of rows, then you will have starting to have a problem there. So So this is the example of analysis. So let me open using a Jupyter. What is the file? Tutorial. Okay. Tutorial. I put it in transportation, in traffic accident, into Manila, and analysis. Python. So, say example here. Oh, to load the data is okay. So again, the same thing. So I have my own library here. Okay. And if you see this, I derive the data first. Okay. And consists of many data. The original variable is until here. Accident counts probably. And then all these new variables from here until the end are derived data, meaning I created my own variables. You got it? And then from there now you can start to check. You see that this is exactly the same as what you did, right? Pivot table. You see? And then you can plot based on district, based on city, right? You can sort it. Okay, whether the accident is actually in the mid block or in the junction. Can you see that? What is the junction type, right? And so on, okay? And what is the control there? For example, oh, majority is in traffic light, right? So what time? What time is the accident time happen? So, oh, apparently in the midnight have more accident than in daytime. You see that? Or what months in the year that actually have more? This is the date of the year, the date of the month, for example. So the pattern is 21 and 11 have more accidents. What month have more accidents? December have more accidents, and so on. Can you see it or not? So whether the accident have in the night or day and so on. So this is the example of traffic accident analysis, similar to what you just did, but of course more data and more analysis. So any comments so far or any question? So if not, let's continue. Or you want to take a rest for 5 minutes? Probably. Okay.
Okay, miss. Oh, okay, sir.
Yeah, I will just do this. So let's continue with learning NumPy. You want? So go to the course, learning NumPy. In Refolio the Moodle, there is learning NumPy. Okay. And if you go there, you will see this. So NumPy is a scientific computing in Python, okay, that you can treat a matrix as if one variable. For example, you can multiply matrix by matrix, you can add matrix by other matrix, and so on, just as if they are numbers. Okay. So I will close this one. Data analysis, we are finished.
Sir, can you share the link to
The link
learning
is
NumPy?
inside Moodle.
Oh, okay. Yes.
Okay. When you check inside Moodle, learning NumPy. NumPy. Okay. So in here you will learn matrix. Okay. And NumPy is very important for many applications. So you would probably use this often. Okay. So let's create a new notebook of Python 3 so that you can practice this. Okay, first thing first. Okay, you need to import, right? You need to import NumPy. Does it work or not? If not working, then you need to install. Everyone?
I
Wait,
think
I'm
mine's
still
working.
doing it.
Okay, Livy,
Wait, I'm still trying.
Michelle,
It's working.
okay. So, next, learning NumPy. Okay. NumPy, in NumPy, you will work based on array or matrix. Okay. So this is called ND array, n-dimensional array. Okay. N can be 1, can be 2, can be 3, and so on. Okay. So first thing first, because we put NumPy as NP here, okay, we shorten the name as NP. So then you can start to say A equal NP arrange 5. What does that mean? That means, okay, you will create an array of 0, 1, 2, 3, 4.
Sir, I think you haven't shared your screen.
Oh, I haven't shared. Is it okay? So NumPy arrange 5. Okay, it's an array of 1, 2, 3, 4. So of course you can change that. So arrange similar to range. Okay, you can have start, end, and the steps. Okay, so you can have arrange 1 to 5. That means 1, 2, 3, 4. So the 5 here is exclusive. Okay, until until 5, that means it will give you until 4 only. 1, 2, 3, 4. And if you put step, say step 2 here, it will give you 1, 3. So until 15, it will give you 1, 3, 5, 7, 9, 11, 13. Is it clear?
Sir, mine has an error.
Okay, can you share your screen? NumPy arrange, not double R.
Oh, okay. Oh, sorry.
Okay,
Thank you.
okay. Rancha, how's it? Joy, Livy?
Mine is working fine.
Okay. Joy, Livy?
Mine is fine to hear.
Mine is also fine.
Oh, good. Okay, then the next things that you need to learn is shape. Shape represent the size. Okay, so say in here I give name A equal, right? Then I want to know what is the shape. Okay, okay, let me put it in different name. And this one. So shape mean the size. So 7 mean 1, 2, 3, 4, 5, 6, 7. So 7 element.
Sir, you haven't shared your screen.
Sorry. Can you see it now?
Yes.
Okay, so shape represent the dimension. Okay, how many elements in that? Okay, so now you can also reshape. Okay, reshape means your element a while ago, say this is 7, right? So let me make it this way. Say B. So before reshape. So this is B. Okay. So now I want to B reshape. Oh, before that. B shape. What is the B shape mean? What is the element of B? 8, right? 8 can be divided by 2. So I will put the B reshape into the shape. The shape is, say, 2 by 4. I can reshape it different way. Instead of 2 by 4, I can reshape it as 4 by 2. Can you see that now? So the same array, okay, you can rearrange, reshape means you rearrange so that, okay, it will have different dimension. Can you see that? Now, when you reshape now, okay, so I call this C example. Okay, so what is the shape of C now? The shape of C is, of course, 2, 4, right? See, I call this D. What is the shape of D? Of course, 4, 2. The same as what you define here. Is that clear?
Sir, why mine doesn't work? Reshape.
Okay, let's check.
Um, I have to find it B.
Okay, you get B. Oh, what is the shape of B first?
1 by
7, right?
oh 7. Oh,
Yes.
so
So
if I
pull
make it
not enough. So
hmm,
make it 17 probably.
and then oh
Then it
okay.
work. Okay.
Yeah,
It doesn't work because the number of element does not.
it's not enough. Yeah.
Yes, it's not enough. Okay. So, Livy, Joy, Michelle, you understand shape, reshape.
Understood, sir. Oh, good.
Good. Okay, you have an array, then you can make it into matrix. Okay, that's the meaning in here.
Sir,
Yes, please.
so shape is like replacing the object.
The shape represent the dimension. How many rows and how many columns. Okay, reshape mean you reshape, you change the shape into a new number of columns, a new number of rows.
Sir,
Hmm.
I have a question. So this one, if I reshape, it goes like, for example, 10, 13, 16, 19, then the second line, second column is 22, 25, 28, 31. Can I make it like,
Can you share it?
okay. Okay, so it's like this, right? So it's 10, 13, 16, 19, 22,
Mhm.
25, 28, 31. If I want the 13 to be here, is it possible? So
Hmm.
10, 13, 16,
Possible. So
it's possible.
possible. So first uh, can you put A dot T?
Here.
No, down there, yeah. Number 15. A dot T capital. Okay, enter. Shift enter. Shift no, control enter, sorry. Is it working? No? What happened?
I think Joy is lagging.
Oh,
I-
so okay.
Hello. I was liking, sorry.
Yeah. Okay, you want to share again?
Yeah.
Okay. When you enter, it will give.
This one.
Oh, sorry, reshape. Reshape to 4 and then T dot T. Reshape exactly to 4 and then dot T. One that you want.
Oh, okay, okay.
Do you know what is the meaning of T there? Transpose.
Oh, so it's matrix.
Yes, it is matrix.
Oh, yeah, yeah. Okay, okay.
Okay. So
so why don't we just make the A dot reshape 4 by 2?
that's
4,2.
let's try that. Okay. Instead of T, now what will happen if you just put A dot reshape 4.2?
Oh, wait. I just go here.
Oh, you get different results.
Oh,
Okay.
yes. Yeah. It'll go sideways first and then go down. Okay.
Yes. That is how they
Okay,
feel.
okay.
Okay. The reshape is the feeling is to go to the
Right.
right first.
Horizontal.
Yes. Okay.
Okay, okay.
Okay. Good.
Wait, this affects the, if we multiply the matrix the
Okay, let's try.
positioning
So-
like this is different. right?
Yes, so you try, you keep name now, P equal A reshape 2.4 dot P, right? A while ago, you just put in number 18 there.
Oh.
You just put it P equal. Okay, so you can show B if you want, okay? And then what you want to do? You want to multiply with what?
With A reshape, this one. Can I name it C?
Okay, C. You cannot multiply that because that is 4 by 2 multiplied by, remember, matrix multiplication, the number of column and the row must match.
Didn't this match? This and this.
So the number of row of the first one must match the column of the
Column of
second
the-
one.
Yes.
So I need to make a new one.
No, you can transpose that. So you can make,
This one.
yes. So C, that one, number 19 is C, right? Then you transpose that one. No.
It will be the same as this one.
No, it's not the same. Look at C first. Okay. There.
Oh, okay.
That. So this one is 2 by 4. Right? So 2 by 4. You can multiply by 4 by 2. So you can put C multiplied by B. Can you try C multiplied by B?
I just go like this.
Yes. Or reverse. B multiplied by. Dot, sorry. Multiply is dot. NP dot. Multiply is NP dot dot.
So B and B dot dot.
No. NP dot dot. DOT.
Oh,
NP dot DOT, and then supposed to be C multiplied by B, right?
do I need parentheses?
Your parentheses, yes. C. Oh, comma. C, comma, B. Right. Yes, correct.
Okay.
You got
So
it,
it
right?
it cannot be the same.
Ah,
Oh, yeah.
the number of, you see this? Okay, let me share the
Okay.
screen. So I will put whiteboard here. Okay. I hope you remember, if I have matrix A multiply by matrix B equal to matrix C. Okay. So what you need to remember is, this one is M by N, the size, huh? This is mean the number of row is M, the number of column is N, okay? You can only multiply if this number of row is also N by P. Okay, then the result of matrix multiplication will be M by P. Okay, you need to remember this. So, very important rule that the number of columns in the first matrix must be the same as the number of rows in the second matrix. Okay, otherwise you cannot multiply. Okay.
Okay.
Okay, please take note on this, huh? Okay, so let's go again to the next screen. So we have arrays. Okay. You can also use what is called linear space, okay, which is similar to arrays. Okay. However, in the third argument of linear space, okay, it's not step, but the number of elements. Okay. In arrays, it's the same as range, right? So you have start and steps. Okay, you remember that. In arrays, you have start and steps. But if you use linear space, you have start and num. So let's do that. So say I have a linear space from 1 to 23 and only 5. There. It will go from 1 to 23 into 5 points. 1, 2, 3, 4, 5. Can you see that? It's an approximation points between 1 to 23. Do you get the linear space here? Lin space is linear space. It's an approximation point, okay, between 1 to 23. And the 23 here is inclusive, not exclusive. Okay, let's try again. 1 to 25, you have 6 points. There. So you have 1, 2, 3, 4, 5, 6 elements. Okay. The first element is 1, the last element is 25. Can you see that? So now you have this value, okay? Now you can also reshape, because now you have 6 elements. I can put it into 2, 3, or 3, 2, right? So I will put 8 here, and then I put reshape of 4, 2. Okay, do you understand reshape now?
Yes, sir.
Yes. It's just a linear approximation of the same space. Okay. Now, in linear algebra, you often meet, say you want to initialize a matrix, right? So the command is zeros or ones. So NP zeros will create a matrix of all zeros of certain size. Say 3, 4, meaning this is the shape, the size. NP1s is the same thing, okay? But it will create a matrix with elements are all ones. You can also create random. So NP random, yeah, 2 times, huh? It will create a random number, okay, consists of value between 0 to 1, okay, and this is the shape, meaning this is the number of rows and the number of columns. So next week we will try to create what is called Fibonacci games. Okay, we will join the NumPy with Pi simple GUI. Okay, and then you will learn to create a game, very simple game anyway. So the point is, to create a games, you probably need a random number, right? So random number can be between 0 to 1, or you can create an integer random number, something like this. So NP random run in is random integer. Okay, let's try this. So let's call this 8. So I want to know what is the shape of the 8. Okay. So random integer have, this is the lowest value. The first element, the first argument here is the lowest value. Okay. The second argument is the highest value. And the third argument is the number of random integer. It is the same as the shape here, 12. So until here, you know how to create a random number.
Sir, for the np random.random integer, the 1, 10, right? 10 is the maximum, right? Is it
It will never reach
including 10
10,
or maximum
excluding 10.
but not including 10?
Yes, excluding 10.
Oh, excluding.
Excluding,
Oh, so without 10. Okay.
yes. So it means if you want to create a binary number, okay, so you just put 2. In fact, you can get like this. You see that? So if you want to create binary number, okay, 0 to 2. 2 is excluding, it will never happen. Okay. This is what you will use. Okay. Of course, after that, you can reshape it, okay? Say, in here, you reshape into 4,3. That means 4 rows and 3 columns. Now, interesting here is you can also use comparison directly in the matrix. So if you look at this, R is this value. Is R less than 7? Okay. If it true, it will always create the true, true, true. If more than 7, it will create false. So that means you can create a Boolean array masking or filtering directly in the matrix. Okay. So this is another example. So I will create a random integer between 1 to 9. Okay. 12 elements. Okay. Then reshape it to 4,3. That means 4 rows and 3 columns. So I print this. And then create a new matrix called M, which is a Boolean matrix. So whether R is less than 7, then M is actually, what is this? Masking, yeah? Masking of true and false. Okay. Then we put R M. What is this? So only when it is true, okay, only when it is true, show the R. So you see this, all the value that is larger or equal to 7 are removed. Can you see that? So the final result here has no numbers that is larger than or equal to 7. Until here, is there any question?
No, sir.
Oh, Joy is not here. Livy, how is it?
I'm still trying the code, sir.
Michelle,
It's working fine.
it's working fine. What happened to Joy?
I think she has a connection problem.
Oh. Is he in Surabaya or in Jakarta?
She's in Surabaya.
Oh. And you are in Jakarta?
Yes.
Okay. So can you follow until masking here?
Yes, sir.
No problem, right? So you can also create an array, okay? Also based rather than arrange or Boolean or NumPy 0 and 1 or random. You can also use tuple or list. Okay, so in this example, you have a tuple 1, 2, 3. Okay, 4, 5, 6 is a list, and then 7, 8, 9 is another tuple. Then if you put NP array, that will create an array of that list or that tuple into single matrix. Okay, so G here is a matrix. Well, let's try this so that you will see. So you see this, G originally consists of tuple and list. Okay, now I have G, which is an array. So now if you put the shape, it's 3, 3. You see that? So the command NP array is useful to create array or matrix from either tuple or list. Okay, so remember, NP array is to create matrix or array from a list or a tuple. Okay. Say for example, I will give you an example so that you will see the difference. Okay. Now I have a matrix M equal to 1, 2, 3, comma. Here I have another one, 4, 5, 6. Okay, comma. 7, 4, 9. So my question to you, can you see this? My question to you, what will happen if I put M shape? Will it work or will it not working? And why?
I think it would be 3 by 3.
No, it will
I
not
think
work.
it will work.
It will not. You try.
Oh.
Because it uses the wrong
Oh, because there's no.
parenthesis or something.
No, it's not because of parentheses. So look at this. If I don't put shape, okay? If I put M, it's working, right? Okay? But if I put M shape, it will not work. It's a list have no attribute shape. Oh, what happened? Why?
We have to use array, NP array.
Yes, you have to use NP array. You know why? Because this is called Python list, multidimensional list of Python, not NumPy. The command shape is only in NumPy array, not in Python. Okay, so to make it correct, okay, so you need to put M equal NP array of that M. I put it M1 now so that you will see the difference. Okay, so I put M1. So M shape still cannot work, right? But M1 shape is now working. Can you see the difference now?
Yes.
Okay, so Python itself also have array or matrix, right? But you cannot do things like in NumPy. For example, M larger than 7, will it work? Error, right? Can you see that? But when I put here M1 larger than 7, it works.
So
So,
it only works with array or matrix.
right. So this is the power of NumPy. Okay. So if you use Python only, you will deal with lists, right? So if you use NumPy, okay, the whole matrix as if one, united into one single value named M1 in here. You see that? So when you deal with only larger than 7, that means automatically, okay, NumPy treat the whole matrix and then calculate it for you for the whole matrix. While in Python, you still need to do it one by one, element by element. Can you see the power of NumPy now?
Yes.
Okay. Otherwise, in here, you need to do for loop, right? For row in M, okay, and then for column in M, right? Correct? So complicated, okay? But if you use NumPy, you don't care about that anymore. Suddenly, you can treat one whole matrix as if they are a number. Very powerful, isn't it? You can, for example, you can M1, okay. So M1 is this one, okay. So now I have an M2, I create M2 equal to M1 transpose. Okay, so let's show M2. So now I have M1 and M2. If I want to add, okay, M1 plus M2, see, I simply add. Okay. Oh, what happened if I use this earlier? This is M. If I use Python, okay, without NumPy,
will not work because
it
it's
will not
not
work.
mathematics. Yeah,
You need to do it element by element, okay?
that's one by one.
Yes. See? Suddenly, okay, your linear algebra, okay, plus, minus, multiply, divide, suddenly become very easy. So I multiply this, okay? There. Oh, I can multiply element by element. See? 2 times 4 is equal 8, right? 3 times 7 equal 21, right? Oh. This is element-wise multiplication. Very powerful, isn't it? So by doing so, okay, now you can think in terms of matrix. Now you don't think in terms of numbers anymore. The way of your thinking now changed because now you can treat matrix as if one number or one variables. Can you see that? In fact, okay, you can also use a complex number in NumPy, which is easy. Okay, so all you need to do is to put the type equal complex. So this is an example. Say this is your array. See, suddenly you have a complex number. Of a matrix of a complex number. Okay, superpower na. Okay. Now, of course, the number of dimension in NumPy is ND array. So that means not necessarily 2D. It can be 3D, right? So here is an example. Say you have a range of 30. Okay, let's do this first. Okay, you have a range of 30. Okay, so that means 0 until 29, right? And then what you will do is now you reshape. Okay. Now you reshape of 2, 3, 5. So,
Oh,
oh, okay. Let's check what is the meaning of NumPy reshape in Google. Okay. So the new shape is integer or tuple. Okay. You have an array as input, and then this is optional. Yeah. So what happened here is now you have 3 by 5, right? You have 3 by 5, it is 15, and your value is 30. So then exactly times 2. So you have 2 of 3 by 5. That means you have 3 dimension here. This is what is called panel, right? So this is the first dimension consists of this. With this consists of 2 dimensions. This is an array of 2 dimensions. Become 3 dimension. So using this NumPy, okay, you can dealing with any dimension that you want. Very powerful, isn't it? Okay. So,
Sir, I have a question.
yes, please.
The previous reshape and the reshape before this.
This one?
For this one, the reshape is like divided the list into two lists, right?
Two tables, front and back. Okay. One table is 2 dimension, correct? And then the table here. So front and back. So become 3 dimension. As if you have a one table is like this, and then another table is in the back of that.
So what's the difference with this reshape here?
This reshape is only 2 dimension. This means only table, right? This first reshape, the one that you put there, if is the 2 dimension, is have row and column. There is no depth, right? The one I showed a while ago. So what is the number here? You have, okay. Can you create a new matrix, new array? For example, can you make a new array consists of how many you want? 40? Okay, space NP, then space 1, 2, or arrange here. Okay. 40. 40. Or something that you can divide by 3. Okay, 40 is fine. Okay, 48. Okay, and then you reshape it now. Okay, now you reshape it into 2, so if you divide by 2, 48 divided by 2 is 24. 24 is 3 by 8. Is that correct?
Yes.
3 by 8.
So this one is
3, 8. Okay, let's try. There. So now you have 2 matrix. Its matrix is 3 by 8. Now you change again. Now reshape. See reshape. Now 3, 2 by 8.
3,2 by 8.
Yes. What will happen? Now you have 3 matrix. Each of them is 2 by 8. So this means the first matrix is 2 by 8. The second matrix is again 2 by 8. Okay. The third matrix is again 2 by 8. As if you have a 3 matrix, okay, in the front and back. Okay, it's a depth. A cube. Can you imagine a cube?
Yes.
Yes. So the first one is the one that in the 0, 1, 2, 3 until 15. The second one is 16 until 31. The third one is 32 until 47.
Oh.
Okay.
So actually it's the same with this, but
yes,
it's 2 dimension and this one is 3 dimension.
3 dimension. Yeah. So
Okay.
you have row, you have column, you have depth.
Okay.
Okay. Of course, you are not even making it 3-dimension. You can make it 4-dimension if you want. So C reshape. What do you want?
Is
So what?
four?
No, you can make it 2, 2, 2, 3, 4. Is it correct? 2 times 2 is, yes. So now you have a 4-dimension.
Okay.
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 Can you see the big space there? Between the first two, can you see the,
Oh, this one.
yes. Okay, there is a big space here represent, this is another. This is like the third dimension. This is again another array. So third, fourth dimension. So you
So-
can create any dimension that you want.
This one. Oh, okay. Okay, sir.
Okay.
Okay.
So it's super powerful, right?
Yes.
Yes. Okay, super. Okay, I think it's time. So, okay, next week I will continue with this NumPy. Okay, you can also read. Anyway, it's already there. Okay, so we will learn the basic operation and changing from array to matrix and stacking, splitting it, transpose, product, additions. I think you have learned this. Anyway, so please read this, okay, and then we will practice next week, and then we will create a game, okay?
Okay, sir.
Okay, so I hope you enjoy our meeting today.
Okay, thank you, sir. See you next
Thank you,
week.
sir. See you.
You,
Yes, sir.
thank you.